Signals and Systems Assignment Help. For any help regarding signals and systems assignment help, visit https://www.matlabassignmentexperts.com https://www.matlabassignmentexperts.com. Email info@matlabassignmentexperts.com info@matlabassignmentexperts.com or call us at +1 678 648 4277. Discrete time sampling recommended problems. P19.1 Consider figures P19.1-1 and P19.1-2 and determine x, q, p, q, x, n, and x, q. P19.2 x, n has a transform x, q. Determine in terms of x, q, the transforms of the signals in parts A and B. A, x, n/2, 1, n even, A, x, n equals 0, n odd, B, B, x, d, n equals x, 2n, i.e., x, d, n is x, n decimated. Problem. MATLABAssignmentExperts.com. P19-2 C. If x, q is as given in figure P19.2, sketch x, q, and xd, q, 4 parts A and B. P19.3 Consider the system in figure P19.3-1. A. If Pn is given by figure P19.3-2, sketch P, q, for n equals 1, 2, and L, an arbitrary integer. MATLABAssignmentExperts.com. B. For each of the discrete time spectra in figures P19.3-3 and P19.3-4, determine the maximum sampling period n such that x, n is reconstructible from its samples x, n using an ideal low-pass filter. In each case, specify the associated cutoff frequencies for the low-pass filter. MATLABAssignmentExperts.com. P19.4. Suppose the signal xt is processed as shown in figure P19.4-1. The system in figure P19.4-1 can be replaced by the one in figure P19.4-2. Find T1. B. Let x, w be given as in figure P19.4-3. Find x, q, and y, q. MATLABAssignmentExperts.com. P19.5 as discussed in section 8.7 and illustrated in figure 8.40 of the text as well as in figure P19.5-1 below. The procedure for interpolation or upsampling by an integer factor n can be thought of as the cascade of two operations. The first system, system A, corresponds to inserting n1, 0 sequence values between each sequence value of x, n, so that for exact band limited interpolation, h, q is an ideal low-pass filter. A. Determine whether system A is linear. B. Determine whether system A is time invariant. C. For xd, 2, as sketched in figure P19.5-2, with n equals 3, sketch x, q. D. For n equals 3, xd, q, as in figure P19.5-2, and h, q, appropriately chosen for exact band-limited interpolation, sketch x, q. MATLABAssignmentExperts.com. P19.6. Consider the sampling systems in figure P19.6-1. Let x, t, and x, w be given as in figure P19.6-2. MATLABAssignmentExperts.com. Let y, t, and y, w be given as in figure P19.6-3. A. Draw x, t, and y, w. B. Find x, w, and y, t. C. Is y, t periodic? Does y, w reflect this property? Optional problems P19.7 Consider a discrete time sequence x, n, from which we form two new sequences, x, n, and xd, n, where x, n, corresponds to sampling x, n, with sampling period 2 and xd, n, corresponds to decimating x, n, by a factor of 2, so that A. If x, n, is as illustrated in figure P19.7-1, sketch the sequences x, n, and xd, n. MATLABAssignmentExperts.com. B. If x, q is as shown in figure P19.7-2, sketch x, q, and xd, q. Consider the system in figure P19.8-1, where x, q, is as shown in figure P19.8-2. MATLABassignmentexperts.com. There is a range of values for n such that, with an appropriate choice for h, q, y, n, will equal x e n. For each allowable positive integer value of n, a, draw x, q. b, find an appropriate h, q, such that y, n, equals x, n. P19.9 Consider the system with input x, n, and output y, n, related by a. For the sequence x, n, in figure P19.9, sketch y, n. b. Express the system as a combination of filtering and decimation. 6P19.10 Consider the system in figure P19.10, where find a constraint on h, n, such that y, kn, equals x, k, for all k. MATLABassignmentexperts.com. MATLABassignmentexperts.com. xn is given by x, n equals -1 equals e. Hence, the Fourier transform of x, n is. Now Pn can be written as. Hence, its Fourier transform is given by. It is clear that x, n equals Pn. Hence x, q equals p, q, S19.2, a, x, n is x, n, stretched by interspersing with zeros, as indicated in figure S19.2-1. Solutions. MATLABassignmentexperts.com. MATLABassignmentexperts.com. x, q/2 is indicated in figure S19.2-3. Therefore, is as shown in figure S19.2-4. A for n equals 1, p, n equals 1. Hence, as shown in figure S19.3-1. MATLABassignmentexperts.com. For n equals 2, hence shown in figure S19.3-2. For n equals L, hence shown in figure S19.3-3. MATLABassignmentexperts.com. B, x, q. The spectrum of x, n is proportional to the periodic convolution of p, q, and x, q. Consequently, with p, q, as indicated in figure S19.3-3 and x, q, as indicated in figure S19.3-4, x, q is shown in figure S19.3-5. In order that x, n be reconstructible from x, n, using an ideal low-pass filter, aliasing must be avoided, which requires that MATLABassignmentexperts.com. I, qm equals 37r/10. Therefore, to avoid aliasing, since n must be an integer, we require that n is 3. For n equals 3, the cutoff frequency of the low-pass filter must be greater than 3r/10 and less than 2, q equals 37r/5. To avoid aliasing, since n must be a positive integer, this requires that n equals 1, i.e., x, n, cannot be sampled. S19.4, a. The sampling period t is 3 milliseconds for the system in figure P19.4-2 to be equivalent to the one in figure P19.4-1. B, K, B, X, Q is sketched in figure S19.4-1. MATLABassignmentexperts.com. From the result of part A, Y, Q is as shown in figure S19.4-2. S19.5. MATLABassignmentexperts.com. So system A is linear. B, take xd, n, as shown in figure S19.5-1, with n equals 4. Then xn is as shown in figure S19.5-2. Take xd2, n equals xd, n plus 1. Then xn is as shown in figure S19.5-3. Hence, system A is not time invariant. MATLABassignmentexperts.com. D, x, q is as shown in figure S19.5-5 for exact band-limited interpolation. A, x, t is sketched in figure S19.6-1, and y, w